Hello everyone, this is Miss Lindsay. Today we're going to talk about two sections, 13.3 and 13.4, systems of equations and graphing inequalities. This should be a little review from what you did last year. So let's go ahead and start with a system here, and let's start with example A. So we have x squared plus y squared equals 5 and 4x squared plus 9y squared equals 40. So we could either use substitution or we could use elimination with this method. Let's go ahead and for this round let's multiply the first one by -4. So we'll use the elimination method. So we'll get -4x squared minus 4y squared equals -20. If we add those, the x's cancel out. We get 5y squared. Sorry, that moved on me. Equals 20. Divide by the 5, and then when we square root both sides, we'll get y equals plus or minus 2. Now substitute that in. I'll go ahead and substitute in twice here. When we plug in 2, I'll choose to put it in the first one. We have x squared plus 2 squared equals 5. So we'll get x squared equals 1. And take square root of that, so we get plus or minus 1 again. Therefore, we have order pairs 1, 2, and -1, 2. Please realize now when I plug in, just like what I did with y equals 2, when I plug in a -2, I will get the exact same result, because when I square a negative here, I'm still going to get x squared plus 4 equals 5, so I'll end up right back in that same place as x squared equals 1. So in our case here, x equals plus or minus 1 as well. So now we get +1 and -2 as an order pair, as well as -1 and -2. So we have 4 solutions to this system. Okay. For B, now this one, a little bit different. On A, we could have used substitution or elimination. On B, we really do need to use substitution, so I'll take the first equation and I will solve that for y. So y equals 2 over x. Now I'm going to substitute that in for the y in the second equation. So I get x squared plus the quantity 2 over x squared equals 5. So I'll get x squared plus 4 over x squared equals 5. In this case here, let's go ahead and clear the fraction by multiplying by x squared on both sides. So we'll get x to the 4th. It'll cancel the denominator when we distribute there, so we'll get 4. And we'll bring through the x squared on the right hand side as well. Subtracting over the 5 squared. So we get x to the 4th minus 5x squared plus 4, and factor that into x squared minus 4 x squared minus 1. And you can either keep going and factor that a little bit more, or you can simply just set both of them equal to 0 and solve from there. So we get x equals plus or minus 2, as well as we get x equals plus or minus, I apologize if that keeps moving on me, x equals plus or minus 1. Now let's go ahead and substitute this in. Since I already have it solved for y equals 2 over x. So we get y equals 2 over +2, y equals 2 over -2. Again, I apologize, that keeps moving. So in this case here, we get y equals 1. When x is 2, y was 1. In this case here, we get y equals -1. So when x was -2, y was -1. And then we get y equals over positive 1, y equals 2 over negative 1. So when x is 1, y is positive 2. When x is negative 1, y is negative 2. Again, completing with 4 ordered pairs. And again, not all of these would be 4 ordered pairs. You could have less than 4 as well. It just depends upon the type of system that you're solving. Go ahead and pause. I would like you to try to go ahead and do C. When you're done, go ahead and push play, and we will walk through that one together. Hopefully this one, the best approach, well, not necessarily the best approach, it's personal preference, but chose to do elimination. Therefore, when you distribute through, cancels the 4. So you'll get x squared minus y squared equals 4. And if we add that to the first equation, the y squared will cancel. 2x squared equals 8. X squared equals 4, therefore x equals plus or minus 2. And now let's go ahead and plug that in. And I'll plug it into the first equation. And again, in this case, I hope you realize that whether we do plus or minus 2 when we square that, we should get the exact same answer for y each time. So in this case, we'll get 4, so y squared equals 0, therefore y equals 0. So our 2 ordered pairs would be 2, 0, and negative 2, 0. And again, I apologize, I'm not sure why this keeps moving on me. And then please, again, pause. For D, I would like you to work through this one, and when you're done, push play, and it'll be worked out, and you can check your answer. Okay, if you check your answers on these, I did a little bit different approach. I did substitution, but I solved this one for x squared. Therefore, I did not have to square again. You could have substituted for y, which would have been fine. I do want to point out one thing here. Please notice when you get the x squared value equals negative 3, this is no real solution for that one. The imaginary number, so our only solution really is when we have the x value is 2, 3, and the x value of negative 2 when y is also 3. Okay, so that concludes our examples for solving systems of equations. Now our next 2 examples are on graphing inequalities. In our first case here, we have y is greater than the absolute value of x minus 1. Hopefully you remember from the past that this should be a V-shaped graph. If you also remember, we had transformations. Your typical absolute value graph starts at the origin and is a V-shaped graph. So you'd have the ordered pairs here of negative 2, 2, negative 1, 1, 0, 0, 1, 1, 2, 2, etc. So this would be our graph here, our absolute value graph of the quantity x minus 1 would be shifted over to the right one. You go ahead and fill up your graph using these ordered pairs. And again, this is right one from our parent graph. You could also just use your graphing utility to graph this as well, or you could simply just make an XY table with your values there. Now, let's actually graph the inequality portion of it. If you recall, greater than or less than are dotted lines, while greater than or equal to, less than or equal to are solid lines. So in our case here, we would want this to be dotted. And let's take a look at our shading here. With our shading, we are saying when are our y values greater than the graph. So our y values below the v, are those greater than the graph, or the ones inside the v, are those greater and the ones inside the v are greater? So at this point in time, I'm just going to put arrows to show that's the direction that I would shade for the first inequality. Now I'm going to go ahead and move to x plus 3y is less than or equal to 12. So again, first we need to graph the line by solving this for y equals mx plus b form. So y equals negative 1/3 x. Again, I apologize if this keeps moving. So now it's in y equals mx plus b form, starting at your y-intercept of 4. And counting a slope out of down 1 to the right 3. And again, please fill in your table with as many, the graph, the coordinate plane with as many points as you can. And this one is going to be equal to, so we should have a solid line. And again, we're saying here in this case, if we would have left this in as our inequalities here, we never divided by a negative, so it would still be less than or equal to. When are our y values less than or equal to the graph? So again, looking below the red line, are these y values less or the y values above? And it is the y values below. So again, I will use my little arrows to designate the area that I would shade. Okay, so now we have to see where these red arrows and the blue arrows would overlap, and it would be right in this little triangular section. So shade in there the best you can. Moving on to our next example. If we take a look here, we have x squared plus y squared is greater than or equal to 9. Hopefully you recall from earlier that both of these inequalities will be circles. So if I just first graph the circle and then we'll take care of the inequality as we did in example A, we know for the first circle, the origin is the center, and then our radius would be the square root of 9, which would be 3. So if we count in both directions, up, down, right, left, just do the best you can here with your circle. Draw in your circle, and it's going to be a solid line because it is greater than or equal to. Okay, and we want to know when is the circle greater than or equal to 9, and hopefully you realize greater than will be going to the outside. All these values on the outside would be greater. And if you're not 100% sure, you can always test a point. Plug those in any ordered pair. If you plug those in to see if it's a true statement or a false statement, you can see if those, which ones are true, which ones are false. Next one, again, our center is at 0, 0. The radius in this case would be square root of 25, which would be 5. So again, count up, down, right, or left 5 from the origin, which is our center. And again, it's equal to, so we will do the best you can with your circle here. And it's going to be a solid line. Now if we refer back to our inequality, it's going to be less than or equal to. So hopefully you realize that would be shading towards the center, everything inside the circle. And then if we take a look at where the red and purple arrows are going to overlap, that is going to be right in the middle, so it makes this donut shape. And that concludes the notes for 13.3 and 13.4.